What I want to do here is center of mass the vector method. So this is for a two-dimensional problem, similar to the one we did with the components. So that's our component axes. Remember we had a 4 kg there. The components for that one was 0, 0. I think we went 1, 2, 3, 4, 1, 2, 3. We had a 5 kg there. The components were 4, 3, and we had a 6 kg at 6, 2. Now we've got equations and we use the component method to find out the center of mass, but we can use a vector method because our equation for center of mass is a vector equation Now the vectors are the x1, x2 and x3, right? Those are vectors. So the rest of it is just scalars. So if they're vectors and they're in two dimensions, we can write them down as such. And as vectors, x1 is equal to 0, 0, right? That's the vector. And x2 is going to be equal to 4, 3. I'm putting the horizontal number on top, and x3 is going to be equal to 6, 2. Again, the horizontal component on top. That is vectors as components. So all we've got to figure out to do these type of equations is how do we multiply a vector by a scalar? That's quite easy. If you've got a scalar times a vector, say a times x1, y1, then that's going to be equal to a x1, a y1. Just multiply each component by that scalar. So if we're dividing all these guys by m1 plus m2 plus m3, which is 15, alright, we can now say that this vector sum for the center of mass has got to be equal to m1 divided by, what's m1? m1 was 4 divided by 15 times the x1 vector plus m2, which is 5 divided by 15 times 4, 3 plus 6 divided by 15 times 6, 2, the vector. Alright, now that's the whole vector equation done. You don't have to worry about dividing by m1s, m2s, m3s, because that's what that 15 is. I just did all the scalars together in one go before I multiplied the vector. So as a vector, that first part equals that. Then we've got 5 divided by 15, right, which is 1/3. So, and we multiply that by 4, and we get 1.3, and then the second component we get 1, right? So that's that vector component. Then we do the next bit, and the top component is 2.4, and the bottom component is 0.8. So now we've ended up with two vectors, and the way you add vectors together, well, 3 vectors, but one was 0, 0, is you just add the horizontals and the verticals. So 1.3 and 2.4 are going to be equal to 3.7. And 1 and 1.8 are going to be equal to 1.8. So as a vector, that's where the location is. And what's at that location? Well, what's at that location is 6 plus 5 plus 4, or 15 kgs. That's the vector approach to these center of mass problems.